Okay, in this lesson we're going to look at communication matrices. So a communication matrix is a square binary matrix. So if you remember, binary means it's a matrix that only has ones and zeros, and a square one is you have the same rows as columns. So we're going to look at, firstly, we call it one-step communication. So over here on the left here, we've got a network diagram, and it's showing, we could just say there are three people, X, Z and Y, and they're showing how they can communicate with each other. So if there's an arrow, when we see the arrow here, this is saying that X and Y can communicate with each other, and obviously Y and Z can also communicate with each other. So when we go to set up our first communication matrix, it's obviously a square, so you work out how many people or things that you have, and we've got 3, so we're going to have a 3 by 3 matrix, and you can see here I've created that. So I've got a 3 by 3. Now it's important that the X, Y and Z go across there is the same order down that way. And what we're going to say is that the message or communication goes from this X and to this side over here. So if we go and set this up, we'll put a 1 if there's a communication there, a first step or one-step communication. So if we look from X to X, there's no step of communication, so we'll put 0. Between X and Y, from X or Y to X, there is, so we'll put a 1. And from Z to X, there isn't, so I'll put a 0. The next we have from X to Y, we know there's a X to Y is a 1, and from Y to Y is a 0, and from Z to Y there's a 1. From X to Z is 0, Y to Z is 1 and is 0. So what we've just done, this demonstrates the direct message or one-to-one step connection between these 3 people. Okay, so we can see I've used the letter C to indicate matrix and this is the one-step direct communication. If I square matrix C, so say, and we looked at this the other day, so that would mean C times C, but we can just pop it into our calculator. So when we square the communication matrix, it will produce a matrix that shows us 2-step communication. So I'm going to do that here and show you what it would produce. So I'm going to square our communication, raise it to the power of 2 on the calculator and press enter. Okay, so I've squared it, and here's what we have. This is the matrix it produced. So this is giving this 2-step communication matrix. So what it does is it tells you how many 2-step communication links there are between the 3 people or whoever you're looking at. Okay, so now we have this 2-step communication matrix. So over here we've got the 2-step. So it shows us how many 2-step communications there are between the individual people or things that you're looking at. So we need to know how to explain what this matrix is. So if you look at this, it's saying this number 1 shows you that there is one 2-step communication link that gets you from X to X. So if you look, here it is. If I go 1 step, 2 step, there's the one option of a 2-step communication of X back to X. Okay, so then we have a look at this 2 here, this 2 is telling us there's 2 options that we can take 2 steps to get from Y to Y. So if we looked over here, we could go 1, 2. That's one option. And the other option is I could go to Z, and back. And there's my other option. So that's why there's a 2, because there's 2 options to get from Y back to Y in 2 steps. So there's 2 options of 2-step communication. And then if we had one last look at another number, so if I look at this one, this is between X and Y, there's one 2-step way to get from X to Y, X to Z, beg pardon. So from X to Z, there's one 2-step, and you can see that we can go down to Y and up to Z. So yeah, that's what. Alright, so from X to Z, there's one 2-step option. So that's where we would go. We could say we went to X to Y to Z, and there's the 2 steps there, how we did that. So when we're analysing communication matrix, so sometimes we can look at 1-step communication, we might look at 2 steps, or we might look at both. So as it says there, if we want to know how many 2-step links there are, we simply take the communication and we square it. If we're asked what the total number of 1 and 2-step communication system, you find that by adding them together. So the important word here is and. They're saying the total number of 1 steps and 2-step communication. So the way you do it is like what it says there that you're going to add. So what we would do is we'd take our communication matrix and we would add it with the C squared. So I'll do that with you. So I'm going to be using the example before, so the communication, and I'm going to add this. So our 1-step communication matrix looked like this. So this was just the C. And then we had our 2-step communication looked like this. And what we're going to do is, so this was C, this is C squared. We've added them together and we get a total. So we know when we add matrices, we just add the like spots. So when we add them together, we end up with this matrix. So we have 1, 2, 1, 1, 1, 1. So so this is X, this was Y, and this was Z. If you add these up, this is giving you the total number of 1 and 2-step communications. So if you add them up, so Y, for example, there has 4 1 and 2-step communication links, and Z has 3. So one might say, who's the best communicator? We're going to say Y because it has the most 1 and 2 steps. Okay, you just need to be careful in the question. So if they ask for the total 1 step, just 1 step, you would just add these up. And so you'd say X has a total of 1 step communication. If you're asked to just the total number of just 2-step communication, you just add these up and you'd say, all right, X has 2 step communication methods. But when they've asked for 1 and 2, you add the 2 matrices and then we get the total number of 1 and 2 steps. So just make sure you're reading the question. So we're going to have a look at this other example now. So we've got Eva, Wong, Yummy and Kim as students in a backpackers hostel. Because they speak different languages, they have problems communicating. The situation they have to deal with is that Eva speaks English only, Yummy speaks Japanese only, Kim speaks Korean only, Wong speaks English, Japanese and Korean. And they've drawn this up in a network diagram up here. So this is the network diagram. Alright, so what they've done now, and you might just be careful with your notes because it doesn't look like this. We had to change. They've set up a communication. This is like the one-step communication matrix. So if you have a look here, we've got Eva. If Eva's the speaker and the receiver is Eva, she's got 0. But she can speak to Wong, and you can see that there, but it's 0. She can't directly, in one step, talk to Yummy and Kim. So there we go. So this has been set up. If we wanted to know how many the two-step communication, we would take this matrix and we would square it to get the two steps. So if you squared this matrix, we're going to see that it looks like this. So we've got 1, 0, 1, 1, 0, 3, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. So just remember, this essentially is Eva, Wong, Yummy and Kim. Now if we have a little look at this 3, so this is 3, so what that 3 indicates, there are 3 two-step communication links between, now remember this is Eva, Wong, Yummy and Kim, between Wong and Wong. So if you have a look, where's these 3? Well, there you go. Here's 1. So 1, 2, and 3. That would be your 3 two-step communication links between between Wong and Wong. Alright, so now we're going to look at these redundant communication links. So if before, like we saw before, Wong had 3 two-step communications, but the message is like Wong going back to Wong. So it's sort of pointless. So if it was, say, an actual message, she's sending a message to come back to her. So that's sort of redundant. It's not really needed. So a redundant communication is when you start and finish at the same spot. So like we saw before when we went from Wong to Wong, back to Wong. Okay? So all the non-zero elements in the leading diagonal of the communication represent redundant links. So if you look here, this is in the two-step communication scenario. These ones are all redundant. So really, if I added them up, so 1 plus 3 plus 1 plus 1, there is actually 6 redundant links in this scenario, because we don't want to talk back to ourselves. So if we look here on our example down here, it says how many two-step communication links shown in C2 are redundant. So we want the redundant. So all I do is go down the leading diagonal here and I add them up. So it'd be 1 plus 2 plus 2 plus 1. So we've got 6 redundant here as well. Redundant links. Okay. If you want to find 3-step communication or 4-step, you simply just use the power. So this power of 3 would be 3-step communication links, and power of 4 would be 4. However, unless the communication networks are extremely large, most of these multi-step links identified will be redundant. So you saw it before when we did the C-squared with the Eva, Wong, Yummy and Kim. We ended up with 3 redundant between Wong and Wong. So the more steps you do, you end up getting a lot more redundant because it's just going back to the same person. Unless it's a really large communication, and you're probably not going to get them in your exam. Okay, so here's another example here where we've got a trout farm. And so these are ponds here, and the trouts can breed with the ponds that are like directly, or they could probably move around. So if we were to set up their first direct link for first breeding, so like the first pawns they get. So directly we could set up a matrix. It's like a communication. So if we look here, P to P is 0, P to Q is 1, and P to R is 1, and P to X I can't directly in one move get there, and P to V I can't as well. Okay, so if we go from Q to P, it is linked, and Q to Q is 0, and Q to R is 0, Q to X is 1, and Q to V is 1. So we could keep doing this, and we would set up our communication matrix, and it would look like this. 1, 0, 1, 0. So if you were adding these up like that, what that shows me is 2. So P has 2 ponds it can breed with. It is directly linked to in one step. Breeds with directly. So, which you can see, we know is Q and R. Okay, just helping you explain. So, in this question they've asked, in terms of breeding ponds, describe what does the sum of the elements in row 3, so I'm going to row 3 here, of matrix W represent. So, for that one, we've got that, add them up. So, there's 2 ponds that are can directly breed with. So, and if you look at that, they are P and X. Okay, so P and X can directly think. So it's the total amount of ponds it's directly linked to, which is 2. Okay, so then they've asked you, here to be W, that should be W squared, has a row. So I've done it over here. If you look down here, this one was matrix W. I've popped it in the calculator. I've squared it, and this one has become W squared. Now, it says in row 2, Q, so row 2 and column 3. So row 2, column 3. And if you remember, so we just remember this is P, Q, R, X, and V, and P, Q, R, X, and V. So we can see that we've got Q and R. It says 2. What does that tell us? That tells us that there are 2 two-step links between Q and R. And you might want to show them. So if you look at Q and R, so one maneuver could be I go this way and that way. So I might say one of those options is I go Q, X to R. And then if we want to look at the second option, I could go Q, P, R. So I could go, the second option would be Q to P to R. So what does that tell you? There's 2 two-step links between Q and R. That's what this 2 explains to us. Okay, so let's have a look at this question here, question 7. It says the communication matrix below shows the direct paths which messages can be sent between 2 people in a group of 6 people, U to Z. So all these are people. And they're always going to tell you in the exam that a 1 means that you can directly communicate with another person, and they'll give a little example so you understand. So it says, how many ways can Y get a message to W by sending it directly to one other person? So this is another way. They want the message to go to from Y to another person to W. So this is just another way of actually asking for how many two-step communication links there are between Y and W. Y and W. So what you want to do is there's going to be Y, there's going to be a step and something else, and then another step, and you'll be at W. So how many? So we know when we want to get two-step communication, we want to take the original communication and square it. So this is what the question gave you, and I did it on the calculator, and I've dropped the picture image here. So this is that, this original, this squared. So if you look, if we go down, this was U, V, W, X, Y, Z. So U, V, W, X, Y, and Z. So I know how many two-step communications this will be between, I'm going to go find between Y and W in my two-step. So between Y and W, we see a 0. So I'm going to say there's a 0 two-step communications between Y and W. Okay, you'd just be continuing on with exercise 11F out of the textbook, and it'll be questions 3 to 5, which are talking about communication matrices, which I want you to do.